Hello everyone, so in this video we are going to discuss regarding this solid solution diagram. We are continuing our phase diagram. So in this now considering about solid solution phase. So what are the examples of minerals or mineral series? Those are showing solid solution behavior in olivine group of mineral. The solid solution series exists between your fosterite and firelite. What do you mean by this solid solution? That solid solution series, that means fosterite is your magnesium olivine, firelite is your iron rich olivine, right? Now thing is that the middle compounds with MgFe olivines, they are also existing. Like in previous case in eutectic diagram, what we have taken, or peritectic diagram also we have studied. So there are two end members. Here it is 100% A and 0% B. Here it is 100% B and 0% A, and here 50% A, 50% B. So in between these two we are not getting any minerals, right? In case of eutectic system we are getting either A or B or combination of that, right? We are getting like that combination of, let's say here if I am taking what are the examples in eutectic? We have taken in eutectic let's say diapside and anorthite, right? Diapside is your pyroxene, anorthite is your plagioclase. Diapside and anorthite. Calcic, it is also calcic. So what happens? Diapside means it is 100% diapside, it is 100% anorthite. Okay, there are some intermediate compounds. There are no intermediate compounds here. In case of peritectic, what we have taken? In case of peritectic, we have taken like this, right? So as you can remember, this is fosterite, this is quartz, in between that is enstatite. Fosterite is a olivine, magnesium olivine, enstatite is a pyroxene, quartz is SiO2, pure SiO2. So there is one middle compound which is existing, okay, and that is the combination of this fosterite and quartz. But in case of solid solution, we can see here, as I have told, in eutectic there is no middle compound. In peritectic there is one middle compound which is the combination of fosterite and quartz. That means the reaction between fosterite and quartz, they will give enstatite. But in case of solid solution series, what happens? There will be existing middle compounds. We can name those compounds according to their composition. Like for example, here I have taken fosterite and firelite. Another example of solid solution in pyroxene group, that is diapside and hedenbergite. There is also a solid solution exists between diapside and hedenbergite. And in plagioclase, it is also showing solid solution between anorthite and albite. Anorthite means calcic plagioclase. Albite means it is sodic, means Na, it is Ca, right? So in between one end member will be calcium oxide, one end member will be sodium oxide, silicate, right? Sodium oxide plus silica, calcium oxide plus silica. So we are talking about silicate minerals only, but I am just considering for this cation, calcium and sodium. Okay, so here calcic silicate, at the another end there is sodic silicate. So in between the end members in between the end members, the minerals can crystallize. The different compositions are there. Like see like this. Here it is 100% calcic or CO. Here it is 100% sodic. In between we can get 80% calcium plus 20% sodium. Similarly here we can get 80% sodium plus 20% calcium. In between also we can get 60-40, 60% sodium plus 40% what? Calcium. Here 60% calcium plus 40% sodium, like that. So we are also getting these compositions are there in the previous case also. In eutectic and peritectic we can also get, if it is 100-100, 90-10, 80-20, 50-50, like that. The compositions are there, but those are not different compounds. Those are not different compounds. Those are the combination of A and B, right? But here in this case what happens, if I am taking any composition in between that, we can name it a different mineral. We can name it a different mineral. We are naming it solid solution series. We are naming it solid solution series. Series means a group of minerals are there. A group of minerals are there. Like here, as I told, this is anorthite and albite. Here it is anorthite and albite. So there is a series exists between anorthite and albite. What are they? What are the minerals? So anorthite means it is 100% calcium oxide, okay, and albite means it is your 100% sodium oxide plus silicate, right? Plus silicate acid. Here it is also plus acid. Okay. So in between that, what are the compounds? Oligoclase, andesine, labradorite, and bitonite. Okay, oligoclase, andesine, labradorite, bitonite. So these are the four compounds, four minerals which can be formed by the combination of this sodium and calcium. These are I can write it like this. These are combination of calcium oxide and sodium oxide. The end members are calcium oxide, calcium rich, and sodium rich. The middle compounds are both calcium and both having calcium and sodium silicates, right? So what are the percentage in oligoclase? That is, as I have told, 80% of albite. In bitonite it is 80% calcium. In labradorite 60% calcium. In andesine 60% sodium. That means 80% sodium plus 20% calcium. Like andesine 60% sodium and 40% calcium. Labradorite 60% calcium, 40% sodium. And bitonite 80% calcium and 20% sodium. Right? So these are having ranges. Like 80 to 60 is 62. I think I am wrong. I think this is Yes, this is 100 to 90, 100 to 90, here it is 90 to 70. These are ranges. Here 70 to 50, it is 50 to 30, and then 30 to 20, sorry 30 to 10, and here it is 10 to 0 for calcium. Right? So I have taken the average like that, 80%, 60%. These are having actually ranges, right? That means 100 to 90% calcium. If there is 100 to 90% calcium and 0 to 10% what? Sodium. Here 90 to 70 means 90 to 70% calcium. Then sodium will be 10 to 30% sodium. Similarly, in labradorite what will happen? 70 to 50 means that will be 30 to 50% sodium. Okay, 30 to 50% sodium. Now it is for in case of andesine, that is 50 to 30% calcium. That means 30 to 70%, sorry 50 to 70% sodium, and here 30 to 10% calcium. That means here it is 70 to 90% sodium, right? And here 90 to 100% sodium. Okay, so I think all of you got this. These are a series of minerals. These are the series of minerals known as plagioclase series. Okay, plagioclase series means there are group of minerals. The end members are anorthite and albite. The end members are anorthite and albite. Albite means your 90 to 100% sodium, 0 to 10% calcium. That means more sodic. Okay, more sodic in oligoclase also, that is more sodic. Here 70 to 90% sodiums are there, sodium percentage is there, and 30 to 10% calcium. In case of andesine, similarly it is 50 to 70% sodic and 30 to 50% calcic. In labradorite it is calcic. From labradorite to anorthite it is calcic. From andesine to albite, that is sodium rich. Here calcium rich. Here 50 to 70% calcium and 30 to 50% sodium. 70 to 90% calcium and 10 to 30% sodium bitonite. Similarly, anorthite is your 100%, 90 to 100% calcium, 0 to 10% sodium. So you can see when I am changing the composition, when I am changing the percentage of sodium and calcium, the mineral is changing. The mineral will be a different mineral. Okay, but all these bitonite, labradorite, andesine, oligoclase, all these they can be called calcic plus sodic. Calcic plus sodic, both calcium sodium silicate. We can write it like calcium sodium silicate. Si3O8 is the formula for your feldspar, right? So calcium sodium aluminum silicate or sodium calcium Si3O8. Okay, either we can say calcic sodic for bitonite and labradorite, and then andesine oligoclase sodium calcium. Sodium is in higher percentage, so sodium calcium aluminum silicate. Okay, so all these minerals, they can be included in one group where the end members are calcium and sodium, and in between that there are four minerals which are having certain composition, which are having certain amount of sodium and calcium. Depending upon the percentage of calcium and sodium, we can define them accordingly, right? So this is known as your solid solution series. That means in between two end members we are getting some minerals. Between the combination of two end members we are getting a different mineral. But in case of eutectic or peritectic system, that is not there. In case of eutectic, you are finding two end members and you are finding a fixed point where you are getting simultaneous crystallization. Like in eutectic we have done like this, right? So this is your simultaneous crystallization point. Similarly in peritectic, what we have done? In peritectic we have done like this. So here it is the reaction point where it will, there are two end members, posterite and silica, let's say, and in between that we are getting enstatite. So this enstatite is forming at this reaction point due to reaction between these two end members. Okay, and here you are getting again simultaneous crystallization between enstatite and silica. But in this case we are not getting the phenomenon like this. We are getting a series of minerals. We will see how the phase diagram will look like. Okay, so in each every middle composition, in each every intermediate composition, we are finding different mineral groups, different minerals, right? So these are collectively known as your plagioclase series. Similarly for olivine also we are getting a series of mineral. Similarly in pyroxene, as I have told, as I have given the example, in pyroxene Heidenbergite and diapside, in olivine posterite and phyllite. So the solid solution series exists between these two end members. So there are middle compounds also which can be defined on the basis of their composition, which can be named on the basis of their composition. Okay, so now moving to the phase diagram of this solid solution series. So it will be unlike the two cases before we have studied. So let's see. As I have told, in x-axis what we are taking? In x-axis we are taking composition and in y-axis we are taking temperature. Right? Here we are taking composition and here we are taking temperature. Okay, let's say anorthite and alpite. These are the two end members. I am taking the example of plagioclase. Anorthite means 100% calcium, 100 to 90, 100 to 90 to 100% calcium. Alpite means 90 to 100% sodium and 0 to 10% calcium, right? Yes, so it is 10, 30, 50 and okay, 50, 70 and 90. Here I can write 0, 10, 30, 50, 70, 90. Okay. So this is your, the second line is showing sodium, and the first line is showing calcium, right? So calcium is increasing in this direction, sodium is increasing in this direction. And as I have named this one, this middle compounds, here it will be oligoclase, here it will be andesine, next it will be labradorite, and here it will be bitonite. Okay, so now which in Bowen's reaction series, plagioclase series is represented. Bowen's reaction series is like that. Here we are starting olivine, pyroxene, amphibole, etc. In this is the discontinuous series, and this is the continuous series. Here we are taking plagioclase. So which mineral is represented at higher temperature? It will be anorthite. The lower end will be albite. That means anorthite will have higher temperature of crystallization, albite will have lower temperature of crystallization. Let's say this is T anorthite, and here it will be T albite, right? Albite is having lesser temperature of crystallization than anorthite. Okay, so the diagram will be like this. Okay, the upper boundary is known as liquidus. Upper boundary is known as liquidus. Lower boundary is known as solidus. Why it is named as liquidus? Because above it all the phases are liquid. Here everything you will get that is in liquid format. Below this curve you will get only solid form or solid phase or crystals. So in between that you are finding solid plus liquid, right? So why this happens I have already told. If anorthite is, if there is pure calcium or pure anorthite, it will crystallize at this temperature. If I am adding something, if I am adding sodium percentage, the temperature will decrease. As you can see, from here to here the temperature is decreased. Here it is the temperature, here it is the temperature. So if I am adding something to the pure anorthite, if I am adding albite percentage to the pure anorthite, that means the composition will move towards this. As you can see, it is 100% anorthite, temperature is here. As I am going, the combination between anorthite and albite, like calcium is 70 to 90, or you can say 70, calcium is 70 at this point, calcium is 70 and your sodium is 30. Calcium is 70 and sodium is 30. The temperature is decreased to this. Here calcium 50, sodium 50. The temperature decreased to this. That means the temperature of crystallization, right? So if I am adding another compound, the thing is same as in previous case. If I am adding something to a pure material or pure substance, the temperature of crystallization will fall, right? But here the crystallization behavior is something different. So let's start. What happens? Let's consider a composition of this. Let's say I am taking this 70. Okay. Let's say I am considering this anorthite 70 and albite 30, or calcium 70, sodium 30. That is the initial composition X. Okay, that is the initial composition X. What will happen? Here the temperature is higher. The temperature is higher. That means it is in liquid form. When it will touch the liquidus only, then only we are going to consider the We are going to consider the solid phase, right? When it will touch the liquidus, then only the substance will crystallize, or the mineral will crystallize. Okay. So which mineral will crystallize first? When it touches the liquidus here, what happens? It will form anorthite rich mineral. It will form anorthite rich mineral. Okay. It will form anorthite rich mineral. This is known as a tie line. This is known as tie line. This is known as a tie line. That means your composition is, you can see the magma composition when it is 70-30, right? Calcium 70 and sodium 30. When it touches the liquidus, it will result in formation of mineral. It will result in formation of mineral which will be more calcium rich. You can see this. Let's say 95, calcium 95. Let's say that is calcium 95. So my initial composition of the melt is calcium 70 and sodium 30. But the first mineral to crystallize is calcium 95 and sodium 5. That means wherever you get the initial composition, wherever you take the initial composition, the first formed mineral should be of high temperature, like the first formed mineral should be calcium rich, okay. Wherever you get this initial composition, let's say I will take a composition here, here Y. So what will happen when it will touch the liquidus? It will not crystallize the same. The composition is, let's say here, right? Let's say sodium 65 and your calcium 25, right? Sodium 65 and calcium 25. But the initial composition is that, but it will not form at first it will not form sodium rich mineral. It will form, which mineral will form? We have to do a tie line. We have to make a tie line here, right? It will crystallize this composition. Let's say about calcium 68 and sodium 32, right? Are you getting? I think all of you are getting. Whenever it touches the liquidus, we'll make a tie line. This tie line touches the solidus at some point. Okay, this will be the first mineral to crystallize. This composition is Y1. This composition is X1. So the first mineral to crystallize will be of Y1 composition in case of the initial composition Y. In case of X, the first mineral to crystallize is X1. How I find X1? I will touch this initial composition. When it will touch the liquidus, I will make a tie line. That tie line will touch the solidus at somewhere. It is having some composition, okay? That is your X1. And always the first mineral to form will be your calcic or calcium rich, okay? Calcium rich or anorthite rich, okay? Then what will happen? So if this is the system, here magma is there, all in liquid phase, all in liquid phase, okay? So what happens here? The first mineral is going to form which is more calcic. So one solid phase is there, number of phase will become 2. One is solid, one is liquid, right? Solid means that is more anorthitic rich, and there will be liquid. So what is the phase rule? P plus F will become C plus 1. In igneous, as I have told, P plus F is equal to C plus 1. C is the number of components. As we have taken, number of component is 2. One is sodium, one is calcium. So F will be equal to C plus 1 minus P. So degree of freedom will become 2 plus 1 minus 2, that will become 1. So degree of freedom is 1. So what will happen? Magma will follow the curve. Magma will follow the curve.